SECME class with Mr. Anahora the class was called Inside and Outside of the Box, Calculus. And basically we took a folder and made, out of one side of the folder, the biggest possible box you could have made with it. It took a series of calculus steps to explain.
Basically we had a sheet to work with, and we were supposed to cut, this was the sheet, we were to cut out sections like these, square sections on each side and on each corner, and twice of that square on each edge over here and down here to make a box something that looks like this. And what we want to do is to find how much of those squares to cut out and maximize the volume of the box we're going to get. And it's a pretty simple procedure. First, we came up with the formula for the volume of the box, which is the length of the box times the width times the height. And looking at the sheet you get, if you're going to have two x's cut out on this side, it's going to be the length of this side minus 2x. The same on this side, but of course on this side it's going to be the length of this minus 4 times, because you've got two squares over here. That's just some technicality, but
so you end up getting your width as, well, we had specific dimensions, other people might have different, but our width was 14.9, which was the distance it was, minus 2x, which were the two squares, and then it was 24.3 minus 4x, because you have the x, the 2 here, and then the x here, multiplied by, and if you know calculus, you know that this would be 2x. And you may not understand it now, but you will understand it when you make the box.
that's true.
So you multiply those together using length times width times height, and you end up, after you FOIL and distribute with
There's a cubic equation. It's not a quadratic equation, it's a cubic equation.
Right.
And well, his intention is to teach this to middle students, middle school students, in order to get them to grasp the idea of calculus at an early age, so that once they get to college, or maybe
high school calculus,
they'll have some kind of idea. So what we're going to do is, we found the volume, and it's a cubic equation, and we're just going to set that to 0. And there's a whole other theory behind that, but for middle school, it's just enough to tell them just to set it to 0.
Set it to 0.
Yeah,
that's all that matters.
and
Then you can section out each part of the problem. The equation actually ends up being 24x cubed minus.
that's the next squared. Yeah.
Oh, 24x squared minus 313x.
Oh no way.
No.
Oh, we
No, it's cubed. It's cubed. You're right.
Oh no, I'm sorry. No, we skipped a very important step. After you get the cubic function, you're supposed to differentiate.
Oh.
Yeah, which is the whole point of calculus, of course. And you're supposed to differentiate. And well, he showed us the most important one. It's called the power rule, where there are tricks where you just bring the power back to the side, and then after you do that, you set it to 0. And then you just solve for x using either the quadratic formula or you factor them out.
Do you want us to explain the power rule?
If you want to, how long will it take?
It's pretty complicated.
It is a little complicated.
Okay. So you do the power rule, you end up with an equation of a quadratic equation, because you've moved down a power, and you section out the equations. The squared part will be your a, just the x will be your b, and then your actual number without an x will be your c. And that's all set equal to 0. Then you use your, what's the equation called?
Quadratic formula.
You use your quadratic formula, which is b plus or minus b squared minus 4ac over 2a. And he explained an easier way to remember that. It can be opposite of b plus or minus the square root of the derivative
of the discriminant
discriminant all over 2a, and then you just find the discriminant as b squared minus 4ac. And if you can do that, you're sectioning it, and you remember it easier. After you plug that in, you get, I don't have the written down, well, the actual answer.
Yeah, you just use the quadratic formula to solve for the quadratic equation we got after differentiating the volume that we got.
Right.
By setting that equal to 0, the quadratic formula, the quadratic equation, we use the quadratic formula to find the value of x. That's basically all we want to do. Now we know how long our x is. X being the little side of the square that we want to cut out. This would be the x, and we want to cut out a square of side x. So we do that, and the rest is just folding it up to make it into a perfect box with a volume of about 977.22 cubic centimeters. That's it. That's how you use calculus to make sure you get the biggest volume.
Right.
So, how did this make sense to you? I mean, was it, did you understand this concept before he taught it? Or was this something that kind of made you see it in a different way?
I hadn't actually learned the derivative rule yet, but I understand it. It's not like I'm seeing things in a new light. It's just a new rule I didn't know.
Uh-huh, cool. What else, anything else that you kind of either learned for the first time or was made clearer?
Well, he mentioned that most math teachers or professors teach calculus in a linear math pattern, meaning you start from the lower level and just continue to build up. But what he does is he brings something much higher up in the ladder of difficulty and teaches it at a lower level, hence preparing the students once they get there. It's basically very simple
He just
for them.
teaches the concepts of every type of math first, and then he goes into the specifics.
Do you think that would have made a difference for you in school, in high school or middle school?
Yeah, definitely. Make a lot of things easier.
If you understand it, then these rules come along, you're like, oh, that makes sense.
Right.
If you don't understand it, and these rules come along, it's all memorization, and that's a lot harder.
So do you think that you could take this back and have a class of your peers do this exercise?
Yeah,
Sure. I would do that.
I'm going to teach my nephew this.
You're going to teach who?
My nephew.
Your nephew. How old
Yeah.
is your nephew?
Right now he's in 2nd grade. He's like,
Wouldn't it be cool to be able to say you've just done calculus and you're 7 years old, 8 years old? So when I hear the word calculus, I think very, very hard math.
It's not.
doesn't
Not
happen.
at all.
Okay. All right. Anything else you want to add?
I
Want to say
like
hi to your mama? Say hi,
You guys
Mom.
rules.
Okay,
Yes.
yeah.
Go
I'm going to put this, okay. All right. University of Houston students here.
Oh, if you're an engineering major, join Triangle.
If you're an engineering major, make sure you're a mechanical engineer.
And join proms.
And join proms. Definitely join proms.
All right.
Play football.